Good evening, Professor. This is Aman. Teammates Raman, Navneet, Shubh, and Manpreet. We have performed simulation of OBC Bank and Arena as well as in MS Excel. So, OBC Bank is an Oriental Bank of Commerce in one of the Indian public sector bank. It has around 2390 branches in India. It is owned by the government of India and it is serving around 20 million customers, and every day are building new customers, and they are like serving a lot of customers at the moment. So why we have chosen OBC Bank? Because one of the major thing is it's a trustworthy bank serving 20 million customers, and they know how to retain their relationship with their customers. They know how to build a good customer relationship, and they provide quality service and customer satisfaction for each and every customers. So I will be discussing literature review, problem statement, level abstraction, types of simulation used, input modeling, and then other of my teammates, they will discuss the both type of simulations, discrete event simulation and the Monte-Carlo simulation for OBC Bank. And they will compare the present results of the present scenario with the recommended scenario after making some changes. And finally, one of my group mates will discuss verification, validation, and strength and weaknesses of our model and conclusion. And then another will conclude the topic. The major factors affecting the waiting time of clients are like, what is the staff of the bank, how many employees have been hired by that branch of that bank, and what is the time taken by staff to provide service to the every customer. So no customer wants to wait in a queue for a long time, and they need to get free as soon as possible. As soon as they enter the bank, they want to be served, and so that they can leave at like in no time from the bank and can continue their other work. So what we have done, we have focused on providing quality service to the customers by trying to reduce waiting time in queue. So we have done simulation in Arena and Monte-Carlo simulation in MS Excel. The major problem is like long waiting times in queue. So we have kept in consideration the factors: average number of customers visiting the bank, the total number of staff present to provide service to the clients, the average waiting time in queue spent by the clients at different counters, for example, the cash counter, loan counter, or opening a new account counter, and the average number of total time spent by the client inside the bank. One of the major resources, the average number of resources utilized by that bank. So we have chosen the microscopic level of abstraction for our simulation, as it is the lowest level, it is a process based, and it has operational representation. So few of our group mates we have worked upon discrete event simulation, and we have used Arena for our simulation model. And we have also done Monte Carlo simulation based on MS Excel. Okay, why we have chosen the discrete event simulation? As we know, the system state will change over the time for the bank. Every time there will be a new customer entering the bank for their services, and maybe at the same time the other will leave. We don't have exact count like how many customers will enter and how many customers will exit, and at what time they will enter and at what time they will exit. So it keeps on changing. The state will keep on changing every second. So another reason for choosing discrete event simulation is because it's a queuing system. So it is possible like at the same time a lot of customers enter the bank, so they have to build a queue to be served by the staff of the customer. And moreover, we are dealing with the arrivals of the customer and departures of the customer, so that is another reason for choosing discrete event simulation. Uh, why we have chosen Monte Carlo simulation? Monte Carlo simulation, as we know, it normally deals with random number of generation of customers, like for any sort of thing like arriving in the bank or arriving at the airport. So what we have done, we have chosen Monte Carlo simulation as the customers arriving in the bank will be random. For example, in 1 hour, sometimes there is only one customer entering the bank, and in another hour it can be like 50 customers enter the bank in another hour, where compared to the one customer enter the bank uh, in last hour. So another reason which leads to Monte Carlo simulation is the impact of risk and uncertainty in the system. And so I will ask my groupmate to continue this presentation, and thank you.
Hello everyone, myself Navneet, and now I am going to proceed with the presentation for input modeling of data in Arena. In input modeling of data, we collected data for 100 working days from Monday to Saturday from the Oriental Bank of Commerce. Next, we have the customer arrival rate. The customer arrival rate is the average number of customers arriving in the bank. Here we are taking the 100 working days for the data. Here is the graph for the customer arrival rate, and we can see that the customers between the range of 300 to 400 are coming every day in the bank. Moving further, in Arena, using input analyzer, we input this data file in the input analyzer, and as a result, we get this histogram. Moving to the next slide, the types of distributions. Distribution can be discrete or continuous in nature. There are different types of distribution, which are beta distribution, Elang distribution, exponential distribution, gamma distribution, log normal distribution, triangular distribution, uniform distribution, empirical distribution, and Poisson distribution. We have performed three distributions in our project, which are normal distribution, log normal distribution, and the beta distribution. The beta distribution is the best fitted distribution for our project, whereas beta distributions is model bounded random variables. It is also known as a fixed upper and lower limits. Also, the normal distribution is a process that can be thought as a sum of number of component processes. The last is the log normal distribution, which is a model, the distribution of a process that can be thought as a product of number of component processes. Now we have the goodness of fit test. The goodness of fit tests are used to assess how fit is the hypothesized distribution is to observe data. Commonly used approaches for comparing fitting distribution are chi-square test and KS test. Now we have the chi-square test. The chi-square test divides the range of the data into the k intervals and tests whether the number of observations that fell in each interval is close to the expected number that should fall in the intervals given the hypothesized distribution. Here is the formula for the chi-test square. As we can see that the value of the square error is minimal, that is 0.008910, and the reason behind the beta distribution is best fit for our data is the chi-square test, which has the p-value greater than 0.05. In order to make comparisons, we have also compared the beta distribution with other distributions also, which are log normal distribution and the normal distributions. As we can see that the value for the square error in both the distributions is bigger than the beta distribution. Moreover, the p-value is also less than 0.05. Next, we have the customer service rate. The customer service rate is the average time at which the service has been given to the bank clients by the bank employees. Here is a graph for the customer service rate. Moving further, we have also generated the histogram for the customer service rate using the input analyzer in Arena. We repeated the same procedure as before in order to fit distribution to this data. We came out with the result that the beta distribution was the best fitted distribution for this data as well. Similarly, we have also compared the summaries of other distributions like log normal and the normal distribution with the beta distribution. And we observed that again the square error value is much higher than the best fit distribution, which is the beta distribution. For service rate, we also observed the values for both the chi-square test and KS test, where the p-values were greater than the 0.05.
Talking about the model design for ARENA model, the system elements of the model are entity, that includes bank clients. Next, we have resources that comprises of bank staff, bank manager, and other counters. Another one is queues. It includes the lines where customers wait to get the service. For instance, queue for opening account, queue for depositing cash, withdrawing money, and asking for a loan, etc. We also have events that involve arrival and departure of the customers. And in the next slide, we can see ARENA discrete event simulation model of OBC Bank. We have depicted the working of OBC Bank through the process map, starting from the client entering the bank, getting the service done, and leaving the bank. This is the initial scenario which has many problems, such as less number of customers being served. Another is more waiting time in the queue to get the service. And we have also seen long queues in this model when we run this model. The OBC banking process starts when the customer enters the bank. First, they are asked if they already have a bank account. If they don't, they have to go to open account counter where the staff for new customer will assist them. Otherwise, the old customer can proceed with the services. The three basic services provided in the OBC bank are: number one, depositing cash; number two, withdraw money; or number three, asking for loans. For the first two services, the customer have to fill the deposit form to deposit money, withdraw form to withdraw money. And after that, they have to wait if the counter is free. Once they found the counter is free, they can get the service and leave the bank. Otherwise, they have to wait for their turn in the queue. For asking loan service, they have to see the bank manager to see if they are eligible for the loan or not. If they prove the eligibility criteria, then they can get loan and leave the bank. In order to improve the service quality of OBC Bank, we have introduced a new counter in our simulation model for the final experimentation, and I'm talking about this counter. Rest of the banking system process remains the same. We just introduced additional counter for the customers who have been waiting in a single queue in our initial model for a long time. So by adding this counter, we saw that single long waiting line split into two small queues, resulting in major improvement in quality of service. Let's see that in our comparison slide of output analysis of both models, we can see that after adding resources, the total number of clients served in initial model was 390, and after the addition, like after making recommendation and improvement in the initial model, we found out that the total number of clients served increased by almost 100, which is a great improvement. We also compared total time spent between the two models. The time spent by the customers in the initial model was approximately 30 to 50 minutes, which was huge to get the service done. On the other hand, we saw that by just adding one counter, the total time spent was reduced to 8 minutes, which is very low than the initial model. After comparing the waiting time in the queues, we have also seen reduction in numbers. So last but not the least, in Arena, we tried to improve the simulation model of OBC Bank, and we recommended the same to the bank manager. And he also agrees to consider the recommendation for this model. And now this is all for Arena, and my groupmate will continue with the Monte Carlo presentation.
So next we have covered is Monte-Carlo simulation. In this we have used random numbers to know the impact of risk and uncertainty on the model. In this we have tested the system under different circumstances to visualize the range of possible outcomes that occur for the choices of actions that we have made in our model. In the next slide, we have covered about black box diagram for Monte Carlo simulation. So here we receive random numbers as an input to Monte Carlo. Along with that, we have a probability distribution function which is applied to Monte Carlo simulation, and hence the end results are computed. In the next slide, we have discussed about Monte Carlo examples in real life. Monte Carlo is used in various fields in real life, starting from engineering to finance, project management to research and development, and then transportation. We can use Monte Carlo techniques in all the day-to-day activities in our life. In the next slide, here are the basics of Monte Carlo method. Here we have discussed about 6 major techniques we used in Monte Carlo. The first one is efficiency. The second one is PDF, which is also known as probability distribution functions. The third one is RNGs, which is also called as random number generators. The next one is sampling, and followed by sampling there is scoring, and after that the last one is uncertainties. In the next slide, we have covered about sensitivity analysis. In sensitivity analysis, we have covered two main parts in Monte Carlo. The first one is sensitivity analysis, and the second one is scenario analysis. So, what sensitivity analysis help us to examine the stability of the result by changing the modeling parameters. In the next slide, we have discussed about the parameters that are under consideration for our project, that is banking system. The first parameter of concern is efficiency. The second parameter of concern is resource utilization, and the third parameter of concern is service given to customer by employee on each counter. In the next slide, we have provided a list of parameters that are under consideration for our system, that is banking system. The first parameter, input parameter, is customer. Customer here means number of customers that are arriving to Oriental Bank of Commerce. The second parameter is employees. So what does it mean? It means that number of employees that are present at different counters in the bank. The third parameter is total staff. It means that total number of employees available in the bank. The next parameter is service time. It means the time taken to serve each customer. The next parameter is wait time. That means the time customer has been waiting for his or her turn or to get the service. The next parameter is next arrival. It is the time for the next customer to arrive for the service. In the next slide, Here it is sensitivity analysis model. We have computed number of customer using rand function, and here the number of customers range between 300 to 400. The next parameter is service time. We have computed the service time using VLOOKUP function. And similarly, we have computed each and every parameter using different formulas for the particular line. In the next slide, it is the output analysis, output for the sensitivity analysis. In Crux, we found out number of total staff decreases with service time. So in general, number of customers should be less than the staff. Therefore, the wait time will be low. Therefore, the output is verified in this general hypothesis model. In the next slide, you can look at the graph. Here, for our model, the average service time for each customer is 7.6 minutes, and the average wait time for the customer is 40.1 minutes.
Hi everyone. So Manpreet talked about the sensitivity analysis and I'm gonna continue with scenario analysis. Scenario analysis is a process in which alternative feasible solutions are used to analyze the possible future outcomes. Rather than concluding just one possible situation, it focuses on different situations that can occur and from them we can choose the optimal one. In this project, we used scenario analysis to examine the change in waiting time of customers and processing time of different tellers. Additionally, it focused on favorable and unfavorable processes so that future scenarios can be concluded. While creating the scenario analysis, the authorized person of the bank creates various scenarios on the basis of data available to them. This includes scenarios like number of customers, waiting time of each customer, processing time of tellers, etc. Basic scenarios that can be concluded are best case scenario, base case scenario, and worst case scenario. Best case scenario includes the ideal projection and is most likely to be implemented by the bank. In base case scenario, calculations can be averaged on the basis of assumption. In the worst case scenario, the results that are obtained can be the worst that can be expected from the system. In input modeling, we are going to mention what type of changes we are going to apply to our model to examine the outputs. To conduct the analysis in our banking system, we are replacing the manual tellers with the automated tellers to evaluate the difference between the waiting time in the two systems. As you can see in the table that in how much proportion the automated tellers are used as compared to the manual tellers, and later on will be compared according to their performance. So now we're going to talk about the model design. To convert the scenario analysis into working model design is very important task. This could help to calculate uncertainties in different scenarios and come up with the best solution at the last. There are some steps that should be considered while designing the model for scenario analysis that are think about the assumptions that you are going to consider, and then for each analysis you want to have consider the same assumptions. Now coming up to our project, here we are going to examine the time used by different tellers. As you can see in the table, when banking is using 100% of manual tellers, they are taking waiting time around 20 minutes, which is decreased as the increase in number of automatic tellers. It reduced to 10 minutes at the end when the tellers are automated, which is half the time of manual tellers. Also, the processing time of the manual tellers is 30, whereas time taken by the automated tellers is only 15 minutes. Here we consider some same number of customers at different percentage of tellers. Now to observe the output of the scenario analysis, we can conclude that the waiting time of the customer decreased with the increase in number of tellers working automatically. Also, the total processing time gradually decreased when we consider the automatic tellers over the manual ones. So to give the general idea about the levels of waiting time, we mention it as very high, high, medium, low, and very low. Now Coming to the benefits of performing scenario analysis, we can say that with the help of this, we can do future planning and dynamic planning. It can also be used for avoiding failures and risks and also predicting losses and investment returns. We have also considered the verification and validation in Arena. In Arena, the verification of the model is done automatically. There is an error window where we can check the errors and correct them. On the other hand, validation is done through hypothesis testing. We took an assumption of 20 customers arriving in 2 hours and check whether the null hypothesis is accepted or not. We also come up with some strengths and weaknesses of our model. The strength is, let's say if OBC bank is open for 24 hours, the revenue is going to increase and the total number of accounts will be increased due to the flexibility of time. And the weakness is, even after running our model for 20 replications for 24 hours, our model can only accommodate maximum of 490 customers, as queue length cannot exceed 150 in Arena. Now coming to the conclusion, in Arena model of our OBC bank, we observed that the clients have to wait in the queue and have to spend more than 50 minutes to get the service done. To improve this, we added resources such as additional counters and staffs. Also, customers can take appointments so that they have to wait less in the queue. And in Monte Carlo simulation, we replace some of the tellers with automatic ones to observe the change. So that's all for our presentation. Thank you.